Well, it just seemed like a few minutes I did 8.2. Oh, wait a minute. It was only a few minutes ago I did 8.2, but here we are at 8.3. Solving rational equations. So again, let's not flip out by the word rational. It just means fractional. Okay, it means equations or expressions that can be represented as a fraction. All right. Now, exercise 1 says use the technique of cross multiplication. Some people have been taught right away and are so much more comfortable with multiplying through by the GCF. Um, not the GCF, the least common multiple it would be. So in this case, all those acronyms kind of fall into each other. In this case, if you wanted to, you would multiply both sides through by 10, because 2 times 5 is 10. But they want us to use cross multiplying, so let's go and use that one. So if we use cross multiplying, this times this equals this times this. Doesn't matter what side you start with. 2 times x minus 1, it's equal to 5 times 4x plus 5. Redistribute. 2x minus 2 is equal to 20x plus 25. I forgot to put the x. I said it, just didn't write it. Let me write it down because I feel like so afterthought. So 20x plus 25. Let's bring the x over. Again, I'm kind of a fan of bringing it to the left side. Some people are more a fan of keeping it positive, and that's okay too. So negative 18x. If you don't mind, in the same step, I'm going to add 2 to both sides. You can do it in separate steps. These cancel out, equals to 27. Divide both sides by negative 18. And x turns out to be, we can reduce by 9 and get negative 3 over 2. How are we feeling? You okay? So, in letter B, we have to be also concerned with a couple of things. These are rational expressions, which means that in our denominator, we do have values of x that will make this undefined. So before I even start anything, I start asking myself, what values of x make this undefined, that it absolutely can't be? So I know that x cannot equal, well, what makes this 0? 2. What makes this 0? 6. So those two, no matter what I get, I have to make sure that my domain does not consist of those two, I shouldn't say domain, my solution, because we're doing equations here. My solution does not consist of either one of those. So let's use the same thing. Now, again, it sometimes is easier to just make sure that you're protecting our binomials. Because now when I look at it, I have to make sure that when I say 2 times 2 minus x is equal to x plus 1 times x minus 6. And if we forget to put those parentheses in, sometimes we get a mess right there. So let's distribute. So we get 4 minus 2x is equal to x squared minus 5x minus 6. All right, in this case, I'm going to bring the left side over to the right side. So I'm going to take my minus 4 plus 2x, and I'm going to line them up with my like terms, plus 2x and minus 4. So this cancels to 0. So I'm left with x squared minus 3x minus 10, which factors beautifully, thank goodness. So you get x and minus 5 and plus 2. Negative 5x and plus 2x gives me negative 3. So now those are my factors. So I know my answers are going to be x equals positive 5 and negative 2. I know they don't match anything up here, so I know that I'm good. So those are my answers. There's no extraneous roots here. All or I could say there are no roots here that make my original equation undefined. Moving on to exercise 2, using the LCD method. That's what I was talking about for the least common denominator method or the least common multiple method. All right, solve the equation 1/2 minus 9 over 4x equals 3 over 4x. So if it's okay with you, I'm going to rewrite it just to make it bigger, because sometimes I feel like it's just too squishy the way it's written in print. I'm going to just remind you, if you rewrite it correctly. I am so guilty of doing that. I'll change the 4 to a 2. I'll change the plus to a minus just for the heck of it. All right, so now I'm going to look for, right now I'm looking at my 2, my 4x, and my 4x. And I'm looking for the smallest number that goes into all 4 of them. So 4x is going to be my answer, or my LCD. So what I'm going to do with that 4x is I'm going to multiply each one of these. So what happens is when I do it this way, my denominators are going to cancel out. This only happens, by the way, when we have an equal sign. Other than that, you have to keep the denominator. So here we're going to cancel this out. This becomes 2. So 2x times 1 is 2x. Here the whole thing cancels out, and I only left with the minus 9. And here the entire thing cancels out, and I get 3. And after doing that one little step, look at the beautiful little linear equation we have left over. It's just lovely. So I have 2x minus 9 is equal to 3. Add 9 to both sides. I get 2x is equal to 12, and x is equal to 6. Now, again, x cannot equal 0. That's really important, because my denominator would be 0 if it was 0. But because my x is 6 and my denominator can't be 0, I'm still okay. We're going to look at a couple of examples later in the lesson where we're going to have some issues. Moving on. So which of the following values of x solves this equation? Now, if by chance this is a question for you, and you're feeling like me right now, it's been a long day, it's about 2 o'clock, I've taught 3 classes today, my head hurts, and I'm thinking, I don't know if I want to do all this work. Well, the other part of me says, well, I know how to use the store button in my calculator. Can I put this whole thing in my calculator and then store to 14, to 6, to negative 8, and 11 and see which one works? And the answer is, oh yes, you can. You can only do that when you have answers that are numbers, though. All right? But, so if we were going to do that, let's just take a second. I'm going to just pull up my calculator and put this in a second. So I'll have it done in just a jiffy. So, the magic of a video. So here we are with our calculator open. The first thing I did is I picked one of my 4 values to try out first. I mean, I guess I would probably go in order, 14, negative 8, 6, but I have a little insight here. So I'm going to try 11. So I put this in, making sure it looks exactly the same way it does on my paper, using my fraction bars, and it does. So when I would hit enter, I get true. So that works. Now, another possible way that you can do it is, and of course, if it said false, you would just use your up button. You would store a different number. So, for example, let's bring it back down again. You'd use your store button again. I don't want to do that. Still true. And you try another one. So let's say, for example, it was false. So I might take 14 and store it to x. Now, we know that it already works. So now it's definitely going to come out false. Use your up toggle button until you highlight it, hit enter, it brings it back, and it retests it. And of course, it's going to be false this time because we know the answer is 11 and not 14. All right. You can also use NSolve. So NSolve, you go to your menu, you go to algebra, and you go to numerical solve, and you put your equation in here. So hold on, I'm going to do it. There we go. So I just want to remind you that when you use NSOLVE, at the very end you have to do comma. A comma is down here over underneath the pi on the left hand side, and you have to put x, whatever variable you are solving for. And then when you hit enter, you'll come up with the right answer. So the right answer is 11 in this case. So two different ways that you can do it using your calculator. When you're like me and it's just been a long day and your head hurts and you don't feel like doing all the math, that's another way to approach the problem. That's multiple choice and it gives you answers. All right, so answer is 4. You can practice that once you get back into class and you have your calculator. So exercise 4, solve each of the following equations for all values of x. So we're going to do the same thing that we just did, except this isn't multiple choice, so we can't use our calculator, but we can use the least common denominator tactic here. Minus, notice how I'm writing it again, so I have extra room. And I'm going to make sure before I start doing any work that I didn't mess up anything. All right, so now I look at my numbers. I have 10, I have 5x, so 10 is going to be my least common denominator. And then I have x squared is my most often used exponent, so it's the highest exponent. So I'm going to use 10x squared to be my common denominator. So what I'm going to do is multiply each of these by 10x squared. Because remember, our objective is to eliminate what's in the denominator. So when this happens, I get the 10s, I get rid of the 10s, I'm left with 1x squared. I'm going to put the 1 in just so you know that that's where it comes from. Same sign, minus. Here, one of these x's goes with one of these x's, so I'm left with 10x equals one of these x's goes with one of these x's, and I'm left with 10x. And this whole x squared goes with this whole x squared, I'm left with 2 times 10. Oh, I knew something was wrong. Sorry about that, guys. Hopefully you think, this is not right, Mrs. Teets, because I forgot to do this. Okay, I feel better. So, with that being true, now, like I told you, thanks for putting up with me because I am a little tired. So we're going to minus 2x from this side. So let's just rewrite this as x squared minus 10x equals 2x minus 20. So I'm going to minus 2x from both sides. And I'm going to, kind of running out of room here. I should have written a little smaller. All right, so I'm going to just write off to the side here, but I'll erase it. So I have x squared minus 12x plus 20 is equal to 0. So when I factor this, I get x minus 10, x minus 2 is equal to 0. So my answers are x equals positive 10 and x equals positive 2. And one more time, I'm just going to go back. I didn't talk about this. X cannot equal 0, right? Because I have 0 in my denominator, but it doesn't conflict with what my answers are, so I'm still good. So finish writing that down, and then I'm going to erase. And then I'm going to continue on with B, and I'm going to need a little bit more room for that, so I'm going to write a little bit smaller this time. Okay, so in this case, I'm going to start looking for my numbers that will make this undefined, so I know that x cannot be 0. I should always do that first, look for that first. So now I'm looking at all my numbers in my denominator. So the largest number that I can take out, or the smallest of the numbers I can take out, is a 4. because I've got a 2, I've got a 1, I've got a 4. So I know my least common denominator is going to be a 4. And you take out the highest exponent, which is x squared. So what I'm going to do now is I'm going to multiply each of these by 4x squared. And I'm going to try to do it up here, which is going to be a little bit small for you. 4x, 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 4x squared. Hold on, I'm running out of room. Squared, 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 4x squared. All right, so now the 2 cancels with the 4 and I get a 2, so this is 2x squared. This x cancels with one of these x's, and I get 4 times 3, which is plus 12x. This entire x squared and this entire x squared cancel out, and I'm left with 4 times 1, which is 4. 4 cancels out. One of the x's canceled out. I'm left with 1x. All of the x squares cancel out, and the 2 cancels out, so I'm left with plus 2 times 1. So I get 2x squared plus 12x minus 4 equals x plus 2. Minus x minus 2 minus x minus 2. So I get 2x squared plus 11x minus 8 is equal to 0. I multiplied them. At least I'm recognizing where I'm making mistakes. Minus 2 and a minus 4 is minus 6. All right, so now I factor this. 2x and x. Now I need this to be a 6 or a 2, a 6 and a 1, or a 2 and a 3. And I actually think it's a 1 and a 6. So this turns out to be a plus and a minus. Right, because I get 12 minus 1. Okay, all right, the brain's working again. So here I get 2x minus 1 is equal to 0. Add 1 to both sides. So 2x is equal to 1, and x is equal to a half. Sorry, I'm going into the writing a little bit. And this one's easy enough to say x is equal to negative 6. It doesn't conflict with our domain restriction, so I'm good. Here are my solutions. Okay, so exercise 5 can be a little challenging. So what I'm going to do is I'm going to do A. I'm going to have you try B, and then I'll put the solutions up for you to copy. All right, so when you're ready, we move on. Now notice this one. I kind of gave you a hint here, and it says solve and reject any extraneous roots, because we do have to put some restrictions here. And sometimes we can't even do the restrictions until we first start factoring. So at first I can see here, I know x cannot equal 5. I know x cannot, I'm sorry, negative 5. It can't be negative 5 or negative 3. I'm going to rewrite it because I don't like it. X equals negative 5, not equal to, and negative 3. Right? Because negative 5 makes this 0, negative 3 makes this 0, so can't do anything about it. This one I gave you a little bit more room on, so we can do a little work here. So x plus 1, I'm going to protect these for a reason. X plus 5 plus 18 over, and we're going to factor this, equals 9 over x plus 3. So surprisingly enough, guess what this factors into? X plus 5 and x plus 3. It's not a coincidence. Because when we look at the least common denominator now, we have to include everything that's been included everywhere else. So right here I have an x plus 5, so I have to include x plus 5. Here I have the x plus 5, so now I need the x plus 3. And I don't have to include another x plus 3 because I already have it. So that's my common denominator. And what we're going to do is multiply each of these by that common denominator. So I'm going to multiply by x plus 5, x plus 3. X plus 5, x plus 3. X plus 5, x plus 3. So when I look at my first term, which I'm right here, these cancel. I'm left with my original x plus 1, and then I also have an x plus 3 left over that I have to multiply by. See, and when they're protected, it makes it just so much easier to do it, to just naturally put them into binomial times a binomial. So the second one, they all cancel, so I'm just simply left with my plus 18. Oh, what am I doing? It's an equal sign. I can get rid of this. Sit on, you guys. Sorry about this. If I had time to re-record, I would. All right? They're canceling out. Why would I have anything left in the denominator? All right, so in this one, this is my equal sign. That's what my difference. If there was no equal sign, I would have to keep my denominator. But because I have an equal sign, I can actually get rid of them completely. So these cancel out. I'm left with 9 times x plus 5. I'm so glad that I actually do these ahead of time, so I have the answers in front of me, and then I never look at them. Okay, so let's factor out. So when we factor this one out, this becomes x squared plus 4x plus 3 plus 18 is equal to 9x plus 45. Let's combine my terms. 4x plus 21 is equal to 9x plus 45. Quadratic, so we have to get everything over to one side, set it equal to 0. So minus 9x minus 45 minus 9x minus 45. Again, you can do this in more than one step if you so choose to. So x squared minus 5x minus 24 is equal to 0. And then factor x and minus 8 and plus 3 is equal to 0. And I have x is equal to positive 8 and x is equal to a negative 3. So remembering what we talked about up at the top here in blue, we said because of our domain restrictions, x cannot equal negative 5 and it cannot equal negative 3. So when we get down here to our answers, we have to reject this one. So the answer is simply x equals 8 is the only one that works. All right, so now I want you to pause the video and I want you to try and do the next one on your own. And then come back and I will talk you through it because we're only at 23 minutes. I can give you another couple of minutes here. Hopefully my brain is working well for this one. So the first thing I want you to do is recognize, we're going to factor first and then recognize which values of x will make this equation undefined. Oh no, I have to reduce first. I'm sorry. I was right. I have to reduce first. So I get 4 over x minus 1, protected, x plus 6, protected, 1 over x minus 2. So this becomes x, look at your answers over on the other side, x plus 6, x minus 2. Right, I got that just by looking at the other two of them. So when we multiply through, we're going to multiply through by this whole thing. Now, once you start getting good at this, you don't have to actually write them out, because you know that x plus 6, x minus 2 is our least common denominator. So in the first one, they're both going to cancel out. We're going to left with 4. In the next one, we have our x minus 1 in our numerator. The x plus 6 is canceled. We're left with the x minus 2. And in the next one, the x minus 2's cancel out. We have a 1 there, so we're simply just going to be left with x plus 6. And you can protect it, but you don't have to really protect that one because we're not multiplying by anything yet anyway. Next step is this distribute and combine like terms. So we get 4 plus x squared minus 3x plus 2 is equal to x plus 6. Let's combine like terms. So I get x squared minus 3x plus 6 is equal to x plus 6 minus x minus 6. And I get x squared minus 4x is equal to 0. Factor out the x, and I get x minus 4 equals 0. So I get x equals 0 and positive 4. And in this case, we have 0 and 4, which does not conflict with what our domain restrictions were, because up here, which I don't think we talked about at the beginning, but I always double check anyway, I know that x cannot equal positive 2, and it cannot equal negative 6. So there's my domain restriction, and that does not conflict with my answers. So therefore, I don't need to eliminate any of my x's. All right, so now if you were to use NSolve with this, because I did check this using my calculator in NSolve because I wasn't sure how it would handle 2 answers. And the answer is it only gives you one of them. It gives you x is equal to 0. So what I just did is I went back and I pulled it up again and I tested for x is 4, and it also came up to be true. So don't always trust NSolve when it's with more than one degree. All right, it'll solve a linear equation, great, but when it gets to those quadratics, it gets a little tricky. So I'm sorry this video went a little longer than usual. I feel like we're going to have to spend a lot of time on this in class, so if you're confused with it, we can go over any of these in class again before we get started on the independent practice. All right, so always make good choices, and I'll see you next time.